multiple choice handout. And then what we're going to do is we are going to go onto the teams, and I'm going to send you a poly poll question. You guys can tell me what you thought the answers to like number 1, 2, 3, 4, etc. were. So the vertex is h comma k, sorry I wasn't recording, and it is in this case 4 comma negative 2. So that's our key point. That's where the V or the tip of the V is going to live. So we're going to go over to our graph and we're going to graph 4, negative 2. Now, in order to know where my next points come from, I kind of have two choices. I can look at the A value, which represents my slope to the right, and only to the right. So in this case, the A value is 2, which tells me my graph is stretched. And again, that 2 represents the slope to the right. So what that means is from my vertex, I'm going up to right 1, up to right 1, up to right 1. Graphs of absolute value functions are symmetric, which means that we have what we call that axis of symmetry. So the axis of symmetry, or the AOS, occurs right here along the line x equals 4. And what that means is that any points to the right will mock those points to the left. So if I have a point to the right one at this point, then I also have a point to the left one of the axis of symmetry. Points 2 dots over will also exist 2 dots this way. Points 3 dots to the right will live 3 dots to the left. And that will help you get your curve of the graph. Connecting our points, we see our absolute value function. Now, when we have the absolute value function, we are going to also be able to create a table. When you're creating a table, it is important to put the vertex in the middle. And then what you could do is look at points above or below your vertex. So that's how we go about filling in our table. Now you can find the f of x values in one of two ways. The first way would be to simply take x equals 0 and plug it in. So 0 minus 4 is negative 4. Absolute value of a negative is a positive. So that gives 4. So 2 times 4 is 8. 8 minus 2 is 6. Plug in 1, you get negative 3. Absolute value is 3. 3 times 2 is 6. 6 minus 2 is 4. And again, same idea. You could plug in these. You can plug in these. I could plug in 5. So 5 minus 4 is 1. 1 times 2 is 2. 2 minus 2 is 0. 6 minus 4 is 2. 2 times 2 is 4. 4 minus 2 is 2. And again, what I should be able to do too is go from the table to the graph, and my points should match. So when x is 5, y is in fact 0. When x is 6, y is in fact 2. And again, the idea is that the table's symmetric. So if 5 is at 0, 3 is also at 0. If 6 is at 2, since 6 is 2 greater than 4, 2 less than 4 will also be at 2. 4 minus 3 is 1. 4 plus 3 is 7. So 1 and 7 will both be at the same value of 4. And again, we can see that over here. At 7, both those 2 points are at 4. So what's nice is the table to the graph to the chart all create that connection. So what our goal or purpose for today is to really investigate what each part of an absolute value graph does, what it means, and how it relates. So we have A, H, and K. Those are our 3 key points. And if you think back to the notes from the other day, I had you at the very beginning of this unit write down the characteristics and the transformations. So that's at the bottom of this page here. So that was on the 2-7 absolute value graphs and their transformations day 1. And again, I know we did that remotely, so what I want to do is kind of just make sure we got all of those key points. So if you want to turn to that page, we're going to go over that really briefly. So you should have real big in there, y equals a, absolute value x minus h plus k. And we're going to talk about what each of those mean. So the a value. The a value tells me quite a few things. A positive a value means that my graph is going to open up. A negative a value tells me that my graph is going to open down. When a graph opens down, we call that reflected. So if the a value is negative, the transformation description is reflected. I wish I could spell. If the h value stays like this and is a negative, then it's actually the opposite of what you think. So a positive h value, which is this form right here, a negative h, tells me that my graph is going to go to the right h units. If inside the absolute value it is x plus h, then that's really like a negative h value, because the minus turned it to that positive. And that tells me that my graph is going left h units. Now k is the same as what you think it should be. So a positive k is going up. A negative k is going down. So again, a positive a opens up, so your v will look like this. A negative a opens down, so your v looks like this. That up and down are different than the k value up and down. And then the last thing we care about is our slope. So the slope also comes from the a value. The a value represents the slope of the graph. If the a value is positive, then we already know it opens up. If the a value is between 0 and 1, doesn't matter if it's positive or negative, the slope is always basically coming kind of from an absolute value standpoint in terms of the stretching or compressing. So if the a value is between 0 and 1, we describe our graph as compressed. If the A value is greater than 1, then we describe our graph to be stretched. If it's between 0 and 1, it's compressed, so it's when it looks like kind of flat and wide. If it's stretched, it's when my graph is skinny and narrow. So again, those are the key ideas. That's what we're really looking at today. So you're going to use the remainder of class time to finish up the review worksheet. And then if you finish that, your tomorrow assignment is the 2-7 review on here. And we're going to check that on Thursday. So your goal for today and tomorrow is to work on this reviewing handout and then that reviewing handout. Make sure down here at the bottom of this page, there are answers for every single one of those 12 boxes. Like this gets an answer, this gets an answer, and then this is the summary. So you're taking what you learned here, taking what I just discussed with you, and summarizing it. We will check and go over all of this on Thursday at the beginning of class. So all these 2 handouts have to be uploaded and submitted before school starts on Thursday morning. Okay? Any questions for me on anything we're kind of working on today? If you get stuck while you're working, I am here. I can put answers up. Mrs. Ward can reconnect me to our class. You can ask me a question on Teams. I am here to answer any and all questions. Those of you that are sitting in on the Zoom, thanks for joining in. I'm also available to you if you have questions.